Okay, we're going to continue looking at operations with signed numbers. And in section 1.5, we're looking at multiplying and dividing them. These are usually a whole lot easier than the adding and subtracting. All right, so first, I just stated the two rules. So the product of two numbers with different signs is negative. What that's saying is if you take a negative number times a positive number, or if you take a positive number times a negative, you're going to get overall a negative. Okay. All right. And then the next rule says the product of two numbers with the same signs is positive. So if two numbers are both negative, the end result is positive. Okay. Or if both of the numbers are positive, the end result is positive. So if the signs are different, then you're going to get a negative. If the signs are the same, then you're going to get a positive. And I just want to take a moment to try to kind of show you some reasons why that might be the case. Okay. For instance, if you had, say you had 3 and you're trying to multiply it by -5. Okay. Multiplication can be thought of as repeated addition. So 3 times -5 really would mean the same as taking -5 and adding it to itself 3 times. And if you added a -5, a -5, and a -5, see how you would get a -15. Okay, so that's one way to think about it. It's like that 3 times -5 just means take that -5 and add it to itself 3 times. And so you need it. That would turn into a negative number. Okay. All right. Another way to think about it is like, say you had -5 times 3. Say it was the other way around and you're trying to reason it out. A -5 is the same as the opposite of 5, right? Times 3. And the opposite of 5, you really can think of as -1 times 5. And then you have that times 3. And then you see how the 5 times the 3 would be 15, but then you have this -1 that you have to multiply by that 15. Okay, let me write it horizontally. So -5 times 3, you could think of as the opposite of 5 times 3, or -1 times 5 times that 3. And then you could do the 5 times the 3, and that would give you the 15, and then you do the opposite of that. And the opposite of the 15 would be -15. All right, so there's a couple ways to kind of think through it. Maybe a simpler way would have been to pull the negative off and think this. Okay, so there's a few ways to justify it. So if the signs are different, doesn't matter whether the number's bigger or smaller or anything like that, just if the signs are different. Like, let me erase this one. For instance, if instead of 3 times -5, say we had 5 times -3, still would be -15. It's just that the -3 would be added to itself 5 times. And in debt 3, in debt 3, in debt 3, 5 debts of 3 is what that's kind of saying. This one's kind of saying you have 3 debts of -5. 3 debts of 5, I mean. So you'd get -15 either way. It doesn't matter whether the bigger or the smaller number is negative. All right, and let's see, if both numbers are negative, maybe one way to think about that, just to kind of try to justify it a little bit, you could think of it as -1 being multiplied by 3, and you could relate it to what we just did a second ago, pull the negative away from the 3, and think about these two. and see how those two would be negative 15? Then you have the opposite of that, which brings it back to a positive. It's almost like the -1 can be brought out of each of those. And then it's okay to rearrange when you're multiplying. And then this is 15. Then you would need to do the opposite of that, which would be -15. And then this one would be do the opposite of that. And the opposite of a -15 gets you back to 15. Okay, so if you have two negatives, it's almost like you could separate out those -1s, and you're doing the opposite of 15. Okay, so 15, the opposite would be -15, and then when you do the opposite of that, you're back to 15. All right, so if they're the same sign, they're positive. Now, this is why I'm glad this happened second, because people shorten this rule to be two negatives make a positive. I hear it all the time. That is true if you're multiplying or if you're dividing. If you're multiplying two numbers that are both negative, your answer is going to be positive. But then people try to use that when they're doing an addition problem, so you have to be careful. Okay? All right, let's go on down a little bit. Turns out that the rules for division is the same as the rules for multiplication. This is just trying to justify that. The rules for dividing, I don't know what's going on. All right, so the rules for dividing sign numbers is the same as the rules for multiplying them. So if you have a negative, let me just do a negative, and it's divided by a negative, okay, or a positive divided by a positive, those are going to equal a positive. But if they're different signs, like a negative divided by a positive, either way, those are going to be negative. So really just different signs are negative. If you have the same sign, it's positive, and that's true for both multiplying and division. All right, now here's how we can justify it here. See, when you're doing 8 divided by 2, division is really the same as multiplication in a sense, or this problem can be written using multiplication. A -8 divided by -2 is the same as keep the -8, change to multiplication, and take the reciprocal. Okay, and so then you've turned it into a -8 times a 1/2. And you know when you're multiplying, if they're different signs, it will be negative. And then when you simplify that, you get a -4. All right, now I'm not claiming that that's the way you're going to work these problems. You won't need to. You just need to think this. Okay, I'm dividing. I know the answer's negative because the signs are different. And then just do 8 divided by 2 and get 4. And there you have it. That's what you really do. Okay. All right, so let's look at a few problems I put in a chart. Let me get you to look at what I'm doing here. So the operation of multiplication, here's the operation of division. Oh, it doesn't like it when I write in the chart. Okay, and then in this first column, we have the same signs, both positive or both negative. See that? And then on this one, the signs are different over here. Okay, so if I do 8 times 2, that's 16. Okay. There's always a little bit of an issue when I make tables to put this into. Let me see if I can get it to do okay. A negative times a negative is positive, and then 8 times 2 would be 16. So both of these are going to be 16. You're multiplying. Okay, on the 2 below it, you're dividing, but you have the same sign. So both of those are going to be positive. And so you kind of just look at that. They're the same sign. They're going to be positive. So then 8 divided by 2. Here, You basically are taking an 8 divided by 2, and you know you're going to have a positive number. All right, if the signs are different, you know these are all going to be negative. Okay, all 4 of them. Okay, now you just do 8 times 2. You decide that it's negative, and then you just multiply the number parts. Okay, man, that really doesn't go in the right spot. Let me write it up way high and see if it goes where I want it. Okay, 8 times 2 would be 16, and it should be negative. Okay, now negative 8 divided by 2. First, just say they're different signs, so they're negative, and then just do 8 divided by 2. Okay, so just do 8 divided by 2. That's going to be 4, and then they're different signs, so it's going to be negative. Okay, now this next chart is just reminding you to be careful. Don't mix up the rules for multiplying, the multiplying and dividing rules, with what you did back with addition in the previous video. Remember, with addition, you just think money. The big mistake people make is that 2 negatives don't make a positive when you're adding. Okay. Also, when signs are different, adding numbers with different signs doesn't always turn out to be negative. Where up here, when you're multiplying or dividing and you have different signs, it's always negative. So it's easy to get them confused. Just do these problems thoughtfully. Try to have it make sense and to understand like in your gut without just memorizing. So remember, when you do 8 plus 2, you've done that your whole life. That's 10. With negative 8 plus negative 2, I wanted you to think money. You're in the whole 8. You have a debt of 2. You're going to be in the debt, in debt, $10. It's not going to become positive. You see that? It's not going to become positive. All right, now on this other one, the signs are different. I want you to notice these don't turn out to both be negative. The first one, you're in debt more than you have. That's going to be negative 6. On the second one, you have more money than you owe. So that's going to be positive 6. So really, if you'll just continue to think money, you'll be okay, and just reason it out. You have more money than you owe. But that's not going to turn out to be a 10, is it? Because you're going to pay off $2 of that debt right there, and you're only going to have $6 left. Here, $2 can cover $2 of your debt, but you're still going to owe 6. So just do those thoughtfully. Okay? All right, now let's continue this because I wanted you to look at when you have zeros and ones in a problem and get you to think about this. So like we're gonna go down in a column. So like 8 times 0 is 0. Now if you do 8 and you have it written over 0 or 8 divided by 0, the 8 would go in your calculator first. This right here is undefined. Calculator is going to give you an error. Division by 0 is undefined. Okay, I'm going to show you why that is. If 8 divided by 0 did or could equal something, then we could do with this like we can do with something like 6 divided by 2 equals 3. Do you know how division and multiplication are related? If 6 divided by 2 is 3, we also know 2 times 3 would equal 6. We could state that. So if 8 divided by 0 equaled something, then we would expect whatever that something was, when you multiply whatever you had in that box, when you took 0 times whatever was in that box, it should equal 8. So you can kind of see why this has to be undefined. There is no number you can multiply by 0 that's going to give you 8. So that's why that's undefined. That's why your calculator will say error, or it'll tell you, it'll even go further. It'll say things like error division by 0. excuse me, if you do 0 times 8, that'll be 0. And if the 0 is on top and you have 0 divided by 8 like that, that won't be undefined. That's going to be 0. Okay. So the one you got to watch out about is when you're dividing and the 0 is on the bottom. All right, let's look at what happens when you multiply or divide by 1. So like, here's some examples. 8 times 1, well, that's 8. 8 divided by 1, that turns out to be 8. 1 times 8, that turns out to be 8. 1 divided by 8 does not turn out to be 8. That turns out to be 1/8. Okay, that's as good as it gets. It's okay to write it as a decimal sometimes, but it's 1/8. 1/8 is not the same as 8. Okay, let's look at adding and subtracting when 0 is involved. All right, 8 plus 0 is 8. 8 minus 0 is 8. 0 plus 8 is 8. But 0 take away 8 is -8. It's like you had nothing and you borrowed $8. You're going to be in the hole 8. Okay. All right. So notice you got to watch subtraction because you don't get the same thing, just like you got to watch division. Subtraction and division, later we'll put a name to this. They're not what we call commutative. You can't interchange the order and get the same thing. All right, then what you're going to experience in your problems, a lot of the problems for the multiplying and dividing, is just kind of doing a mixture of problems that are a lot like what you did in section 1.1, but your answers can turn out to have integers. So you have to do a lot of the, you have to work with positive and negative numbers, okay? All right, so we're going to go through several of these. Why don't we go through and do some even ones? Okay, so let's look at 54. All right, so 8 minus 2 times 5. The multiplication would have to happen first. You can do the 2 times 5 and get 10. So you'd have 8 minus 10. And then 8 and a -10, that would be -2. So that would be your answer on 54. Okay. With 56, leave the -11 for a moment. What I'd really like you to think about here, well, never mind. What you would do here is the multiplying. That would give you a -18. And then you're supposed to be doing -11 minus -18. So remember how you can keep, change, take the opposite. So a -11 and a +18, in the whole 11, you have 18. That's going to turn out to be +7. All right, let's look at 58. Okay, 4 minus 7, that would be have $4, take away 7. It's like the 4 is positive, the 7 is negative. That's going to be -3. And now you're going to multiply a -5 times a -3. That's going to give you a +15. +15. 2 negatives multiplied would be positive. All right, now 60, a lot of people make a mistake on problems like 60, 59, 60, 61, 62 because of the 5 plus 3, 7 plus 2 being right there in front. You need to follow order of operations. You should do the 6 minus 4 first. In that case, you'd get a 2. Do not say 8. You do multiplication first. Do the grouping symbol. Then do the multiplying and get 6, and then do the 5 plus 6. And that would turn out to be 11. 62 is a lot like that. Resist the urge to put the -8 plus 4 together. It shouldn't happen until after the multiplication is done. Take the 5 minus 7 and get a -2. Then multiply by 4. 4 times negative 2, they're different signs, so that'll be negative. That turns out to be negative 8 plus a negative 8. And 2 negatives don't make a positive. 2 debts turn out to be negative 16. All right, on 64, you're just doing 8 minus 9, 8, and a negative 9 would be a negative 1. I'm thinking money. Have 4, owe 12, that'd be a negative 8. But then I got to multiply those two when I'm finished. And when you multiply two things that have the same sign, it's going to be positive, and then just do the 1 times 8. Decide what the sign is going to be, and then just multiply the numbers. Okay? Okay. I think we can skip to 68. Look at 68. You got to watch it. Got to do what's in the grouping symbol, then handle this multiplying. So negative 9 and a negative 4 would be a negative 13 because you got them and you're just combining those. But then you're multiplying that by a negative 2. Okay, so that's going to be a positive because you got a negative times a negative. It's a positive, and that would be 26 plus 10. That would be 36. So these problems are really just order of operations, but just be aware you're going to have positive and negative numbers to deal with. Okay. So let's look at 70. You're going to do 4 times negative 8. That's negative 32. Then the 4 minus 15 inside there would be a negative 11. You have 4, you owe 15, you're still going to be in the whole 11. But you got absolute value around that. So this is going to be negative 32 plus positive 11. Now, the signs are different. I'm so sorry. Signs are different. You owe a whole lot, but you can use $11 to pay off some of that. So you're going to wind up with only a $21 debt left. Be your final answer. Okay. All right, let's move down a little bit. All right, 72 is the first one that had the horizontal fraction bar. So look at the top. See how the top has no operation between the negative 12 and the negative 5? The parentheses really do indicate multiplication there. But in the denominator, you've got that minus sign. So the numerator is a negative 12 times a negative 5, which is a positive 60. Negative times a negative. When you're multiplying, they have the same sign. It's going to be a positive. But down here, this is really 7 and the opposite of negative 5. 7 plus 5. Keep, change, change. So you really have a 12. And then 60 divided by 12 would be 5. Okay. All right, let's see. Why don't we jump to one like 76? Okay. Here, I would do the negative 12 times 4. Signs are different. I'm multiplying. It's going to be negative. 5 times 3 is 15. There's a plus sign in between. Down here, this is negative 14, and then I have the opposite of negative 3, or keep, change, change. So it'd be negative 14 plus 3. So on top, I'm going to be able to pay off $15 of that debt. So I'm going to take 15 away from 48. So that would be 33, and I would owe that. In the denominator, I can use 3 to pay off some of this, and I'd be down to just owing 11, wouldn't I? And then the negative divided by a negative, both are the same. That's going to be positive when you're finished, and 33 divided by 11 is 3. All right, let's see. Maybe do one with absolute value, like number 80, and then we'll do 82. Well, let's go ahead and do 78, 80, and 82. I think that's the end of it anyway. Yeah. Okay. So let's look at 78. 5 squared is 25. 7 squared is 49. I have minus between those. Down here, I have 3 plus 3, which is 6. And I have 2 times that 6. All right. Let me finish the 78 down here. Bring this down here. So I have the 25 minus the 49 over the 2 times 6. That would be 12. So 25, and then I have 25. I have a debt of 49. I'm going to subtract 25 from 49. That gives me 24. But see how I owe more money? So that'll be negative. Okay, or if you prefer, you can keep, change, and take the opposite. Keep, change, change. Then you can think money. I have a debt of 49. I have $25. I can pay that down. All right, the denominator is a positive 12. Okay. And then that's negative 24 divided by 12. Sometimes we do this kind of thing and don't go far enough. That would be negative 2 over 1, but negative 2 divided by 1 really is negative 2. All right, so I noticed they were different signs, so I know it's negative, and then I just work it out. All right, so let's look at 80 next. All right, so I'm going to get ready for it. So I have a negative times a negative, which is a positive. 27 times 2 is 54. I have 6 times 4 inside the absolute value, which is 24. Okay. In the denominator, I can do the negative 2 times the positive 3, and they're different signs, so it's going to be negative. Now, watch what I'm going to do here. You can either be thinking negative 2 times 2 is going to be negative 4, or you can think 2 times 2 is 4, and then I've got to subtract. So both ways of thinking on that are going to work. All right, then I would do the absolute value of 24, which would be 24. Then I'd do the negative 6, take away 4, which would be negative 10. Okay. Then the 54, take away 24, that's 30, positive 30. And we have a negative 10. All right. And then down here, you have different signs and you're dividing. So you know your answer is negative, and then 30 divided by 10 would be 3. Okay, so these problems are just order of operations, but you could be adding, subtracting, multiplying, or dividing, and you could have negative numbers. We couldn't do that to you before. All right, let's look at 82. Negative 5 times 2 I could do. Over here I have a grouping symbol, and I've got multiplication inside there. So I can do 3 times negative 2. They're different signs, just like these were. That's why it turns out negative. Down in the denominator, this is not multiplying. It's a negative 3, take away a negative 1. You can do the whole keep, change, take the opposite. Keep, change, change. That becomes negative 3 plus 1 down there. I'll write it that way first. And you're combining. You're just combining, like adding those. So you have a debt of 3, but then you have $1. So that's going to be negative 2. Okay, then on top, we have a negative 10 plus, and then inside here, this is a negative 6, take away 4 more. It's like the 6 is negative and so is the 4. That doesn't become positive because we're adding these, we're combining these. Okay, or if you prefer, you can keep, change, change. The 6 and the 4 are both negative. A debt of 6, a debt of 4 would be a debt of 10. Okay. And then a debt of 10 and another debt of 10 would be a debt of 20. Still negative. 2 negatives don't make a positive when you're adding. You don't get out of debt. But you know, right here, we have 2 negatives and we're dividing those. That will be positive. And then 20 divided by 2 is 10. So your answer is 10. All right, so this just takes some work. Do these problems thoughtfully. It really pays off if you think about these as you're doing them. Do them yourself and then see whether they're right or not. Don't just type stuff into a calculator. It really helps to build your integer skills. By far, if you asked any math teacher in the world, what's the most common issue? It's usually people messing up their signs, putting the positives and negatives, having those all wrong. Okay. All right. So this was multiplying and dividing signed numbers. And the new idea for that, let me go back, was just if the signs are different, you know the answer is negative. If the signs are the same, you know the answer is positive. So think about what the sign should be first and then work out the number part.